I have no clue what you just said, but it sounds awesome. Wow, so many people here. That's really awesome. I did not expect to see so many faces. So that's really made my trip worth to Korea. So it's my first time here. Bear with me. Pretty excited. Welcome to my session on HTML5 offline applications. Before I start with the topic, let me introduce myself. So, as you just said, my name is Stephan Hocdorfer. I'm from Germany. I live there. I run my own company there. The company is called BitExpert. I'm pretty happy that in 2 days we celebrate our 10 years anniversary. So our main focus is developing web and mobile applications for our clients. I'm currently being in the position of head of IT, which means I'm responsible for all the technology-based decisions. How to manage our infrastructure, how to work with our teams, how to improve the technology stack in the project, all sorts of stuff. If you have any questions, there is my email address, there's my Twitter account. Feel free to ping me. I'm happy to answer all your questions. As you can see, I'm more of a server-side kind of guy. I'm doing a lot of PHP. I'm pretty interested in DevOps, automation. So I'm really scared to give this talk to an audience like you, although I've done the talk 15 times in the last 12 months. But anyway, I love the fact that browsers are awesome, and I can show you pretty amazing stuff. So that's just a bit about me. Now I'd like to get a feeling of who you are and what your background is. So how many of you are back-end developers? Would you please raise your hands? Okay, just a bunch. How many of you are front-end developers? Okay, a few more. And the others do not know? Or just that works all over the place. No, just kidding. Okay, let's get started. You probably all know that. That's a smartphone. Who of you has one? Or more than one? Oh yeah, that's what I thought. So basically everybody, right? Thing is, we are living in an age of smartphones, right? We use it daily on a daily basis. We do not use it only for speech or for texting. We are using it for mobile applications as well. In some cases, it could be even a replacement for our desktop PC or laptop or whatnot. But as you can see in the picture, there is this white area, which I'd like to call the famous white screen of death. It's like the blue screen, but in white, which basically means that the application tries to load some data from the internet, but somehow has no connection or just anything failed, and you just wait over and over again and see this bad white screen. That's not nice, right? The idea is that we have to rethink how we design our mobile applications. It's not that, right, specifically web applications, it's not that we just take the web application and put it offline and it's just fine. We have to think the other way around. We have to think offline first. So this is actually a movement started a couple of weeks ago. It's called offlinefirst.org. You might want to check it out. And the idea is really, how can we improve all our applications that and focus on this run offline first approach? How does this affect the UI? How does this affect how the application is laid out? All the things like that. So we have to completely rethink how we did it in the past and really focus on this offline first character. Our question really is, how can we create offline applications? Well, obviously, on the one hand, we could go the native way, right? Writing a native application, but that's probably not why you're here, obviously. So we're going the HTML5 part. But I have to warn you, HTML5 is not yet a fixed standard. So in 2014, at the end of 2014, the core specification of HTML5 will become, or will be set to recommendation mode, which basically means it won't change anymore. But this affects only the core part of the HTML5 specification. And all the APIs I'll show you today are not covered by this fact. So it may or may not be that in the future, these API will change as they have in the past. So you need to be aware of this fact. And you need to take this into account when you're developing offline applications with HTML5. Now, there are companies like Facebook, which completely moved away from the HTML5 path because they said HTML5 does not work for them, and they just turned their development completely over to the native part. Maybe they did expect too much from HTML5. Maybe they did it a bit wrong. I don't know. I can't really judge. On the other hand, we have companies like Sencha, who are the creators of a famous, fabulous HTML and JavaScript framework. They just go the other way around. They say HTML5 is really awesome and it's really ready for prime time. And what they did, and I linked the slides, so the slides, it's an HTML5 slide set. You can click on the image and you will jump to the blog post. What they did is they created a sample application which mimics the Facebook application completely in HTML5. And they showed some awesome stuff like the auto rotation, which the native Facebook application does not do by default. So this is supported by the browser. They show how fast the application is, and it's all done in HTML5. And there you can really see, when you see the video, you will really see how awesome HTML5 is and what you can do with it. Okay, let's go back to the question, what does offline really mean? When we're talking about offline, we are facing actually two different roads. On the one hand, we are talking about putting the application itself offline, like making it possible that the HTML, JavaScript, images, CSS is downloaded and can be run offline. And on the other hand, we're talking about content, data, content that you provide as a user of the application, or content that is provided by the server and downloaded, or both ways. These are two different approaches, and they have to be handled separately, so we have to focus on each of them individually. So first, let's start with the application. To get an application running offline, you need so-called offline containers. You have the choice between two paths. On the one hand, you could use a hybrid container, and on the other hand, you could use the HTML5 application cache. Now, a hybrid container, as I would describe it, it's like a marriage. It's like a marriage between a native application plus the HTML part, the JavaScript, and so on. It's all packaged in one application and shipped to the user. You can put it in the application stores because it behaves like a native application, and the end users probably do not really know that this is an HTML5 application. The benefit of this is that since we have this native part, we could also access the hardware, like the camera, the accelerometer, and whatnot, which obviously something we cannot do from within the browser if we're just focusing on the browser engine. So that might be a path that you want to go to. The other idea is using the application cache, which is basically an extension to HTML5 that allows a web browser to download certain files of the application in the background, store them locally, and execute them, run them when you launch the application. Now, how do we do that? Let's take this, for example. That's the most basic HTML5 page you could ever come up with. To enable the application cache, we have to add an attribute, which is named manifest, to the HTML element. And we define a file which resides on the server. In this case, we call it cache.manifest, which would hold all the list of files that should be downloaded in the background. Now, the file looks like this. So the first line reads cache manifest in capital letters. So you have to write that. That's part of the specification. The second line we just ignore for now. That's a comment. I'll just come back later on. And down below there, you see 4 resources listed that the browser should download when it accesses the application the first time. The first 3 are relative paths. The fourth one is an absolute path. It doesn't really matter what you do. The browser will figure out the correct URL and download the files accordingly. But you can do more with that. So this is a different example. Again, first line reads cache manifest. We have a comment in there. And then we have what the specification calls 2 sections. We have a network section and a cache section. The network section describes all the resources that should never, ever be downloaded. So all the resources listed there will always reside on the server, and an internet connection is required to access these resources. And all the resources listed in the cache section will be downloaded by the browser in the background. Be aware that the browser does not check how big these files are. So if you refer to a file that is probably 2 gigabytes or what, the browser will download it. The user is not notified in any way that he's downloading a massive amount of data. So that's really bad. So be nice to your users and just provide what's really necessary. Another idea is this. Again, first line reads cache manifest, the second line is the comment. And we have 2 sections in this case. The first one is called fallback, and the second one is called network. The star in the network section just says download or use all images from the production server. Do not download anything. So if you request a resource, we'll download it from the production side. The fallback section is there just in case that we do not have an internet connection. So what happens now is when the browser hits the application the first time, he will read the manifest file. He will see there is a fallback section in there with a file referenced, offline.html. The browser will download that file, so it can keep a local copy. And in case you switch off the network connection, and restart the application, it will display this offline.html page instead of your normal application. So what you can do with this approach is like give the user a hint that they are currently not connected and they should check their Wi-Fi settings or whatnot just to make sure that they're online and can work with the application again. So that's a different way of dealing with the app cache. Obviously, somehow the user needs to get the latest data. So let's say I changed the logo of my application and I want to distribute it to all my users. Now that does not really happen automatically. It has to be triggered by the application, and we could do something like this. We define a onload listener, which is fired whenever the page is loaded or started. In this listener, we define a update ready event that we hook into our window.application cache object, which is responsible for managing the application cache. And the update ready event is fired whenever the browser detects there is a change on the server side. Now what we do is we check if the status is indeed update ready. If it is the case, we call swap cache, which basically discards all data that is stored locally and just downloads all the new ones from the server. If that's done, we present the user with a dialog which says, there is a new version available. Would you like to load it? And if the user clicks yes, the window gets reloaded and will see all the latest resources. I'll come back to that in a moment. That sounds pretty easy, right? But I can tell you from the bottom of my heart, it's not. There are a lot of pain points that you are facing with or you need to be aware of when dealing with the application cache. I just list a few. There is an awesome presentation by a guy named Jake Archibald. The presentation is called Application Cache Douchebag, where he, I think, for an hour describes all the bits and pieces and how to work around different problems when dealing with the application cache. So first of all, you have to know that files are always served from the cache. So when I have a file downloaded like a logo and I change it on the production side, it will not show up for all the users that already have downloaded the logo. All new users will get the new version, but the users of the old version will not see the update. To distribute the changes on the server side to the clients, you have to change the manifest file. And this is where the comment you've seen before comes into play. So the idea is that you have to change at least one character in this manifest file to make sure that the client browser recognizes the change and will download the new or changed resources. So the idea is that you put either a date in it or a timestamp or a version number or whatnot, just anything that you can change for each update. And the browser will detect that the manifest file has changed, will check the list of resources in there, and just re-download it, the resources if they have changed compared to the local copy. That should be a no-brainer. So non-cached resources will not show up on a cached page. I mean, that sounds clear to me, at least. I have a cached page. There are stuff in it which is not cached, so how could that thing show up? So if you go back to the example with the offline.html page, which is shown when I have no connection, if I would have an image in there, I would need to list it in this cache section so that the image also gets downloaded when the application is initialized. For bigger sites, it's really worth that you try to cache anything that you can. However, you should never ever cache the manifest file itself. You always have to make sure to deliver the latest version of the file to the end user. You do not want a proxy to cache that file and deliver an old version to the user, because you probably could refer to old versions of these files or files that do not exist anymore. In the case of files that exist not anymore, it will completely invalidate the cache, which is really bad. So you have to check to make sure that all the links do work and point to the right files when you create this manifest file. So, but if you follow these rules, it's been really amazing to play around with that. So the first time I tried that, I was sitting in our office. I had my iPad with me. I launched the application. Everything showed up. I switched the Wi-Fi off, started the application again, and it worked. This was one of the few times in my life where I was like, holy crazy shit, this is really awesome. Try it yourself. OK, so that was the application part. As I said, it's not only about application. It's also about data. And how can we store data locally? Well, we got 4 different ways of doing so. We got something that is called web storage. We got the Web SQL database. We got IndexedDB. And we got the file API. The file API is something I won't cover because of the short time span I have for this presentation. If you're really interested in that, just go Google for it or ask me. I'm here for the whole day. I can show you the extended version of the presentation where I have this in there. So let's get started. Web storage. Now, web storage is basically a simple key value store. It comes in 2 versions or 2 variants. We are talking about local storage and session storage. Now, for the guys working on the server side, local storage is a bit like Redis, which is more of the persistent variation. Like, I put something in the local store, I close the browser, I open it again, and the data is still there. Session storage, on the other hand, is like Memcache. I put something in, I close the browser, I open it again, it's gone. So it's just available for this session. So in most cases, when you want to deal with web storage, you probably want to go for the local storage part because you want data that is persistent. OK, how does that work? Well, this bit JavaScript code, we define a variable named value. It's a string. We could either use a method call to put data in the local storage. So if your browser does support local storage, there's a local storage object, which has exactly 2 methods, setItem, getItem. SetItem, we pass a key, and we pass the value. And getItem, obviously, we pass the key. If somehow you don't like method calls, you could use the array accessor. If you don't like the array accessor, you could also use the property accessor. So just use what suits your needs best. The downside of this is that we can only store strings in it, as we did right now. If you want to store an object, like this one, we have to apply a bit of magic, at least. So basically what we do is we create a JSON representation out of this object, and we persist the JSON representation. That means since we persisted the JSON representation, when we want to retrieve the item, we have to parse it again. And this shows at least a bit of the limitation of this approach, because obviously you are not able to really search the local storage for certain stuff. So if you would want to implement a search method, you would need to extract all the objects or all the items, create objects from it, check which properties you want to search for, and then just give them back to the caller. So if you want to implement some complex logic, this is probably not the best idea. Pros and cons. Pro, it's named being the most compatible format up to now. Yes, it works even in IE8. So it's really supported by all the different browsers, all the current ones. We don't have any HTTP overhead. Like traditionally, we probably would put the data in a cookie. The cookie would be sent to the server back and forth, which is pretty stupid for data that we want to keep locally. So this is all done locally, so there is no HTTP traffic involved. Con, as I just said, the data is not structured. We are just storing strings. Now, depending on your needs, this may be okay, but yeah, it may be not. So you really need to be picky about the method that you want to use. And the real downside is that we do not really know how much data we can put in the store. So we put data in, we put data in, we put data in, and at some point, we simply get an exception back, which indicates, hey, the store is full. We do not know when this could happen, which basically makes it really hard for us to figure out a way of which items can I delete from the cache so that the new item will fit in, or don't I put this item in, or what do I do in this situation? And depending on each browser, you have different kinds of storage quotas. So typically it's 5 megabytes, but you cannot trust that size. And obviously, you do not know exactly how big your object or your data is that you want to persist. So that's really bad. But for smaller stuff, this is really cool. So web storage is probably not the best way. There's something else. For example, the web SQL database. Now, as the name implies, it's a SQL database running in your browser. Now, as I said before, I'm a server-side guy, so talking to databases is what I do on a daily basis. So it's really awesome for me to have a database in the browser because I can do all the fancy stuff that I can do on command line in my browser. Now, all the implementations out there are based on SQLite, which is a smallish SQL engine, and it was really easy to embed in the browsers. You can get SQLite for the console as a command line application, and the exact same syntax that you can use on the command line, you can use in your browser as well. How can we work with that? If your browser does support the web SQL database, there is an open database function. The first parameter would be the name of the database that we want to create. The second parameter of the function would be a version string. The third parameter is a description of the database. And the important part is the last piece, which defines the size of the database. So in this case, 5 megabytes. So over here, I can really define how big my database will be. There are some browsers that would limit these things, but at least you are sort of free to decide how big my database can be, and it can grow over time. So if I need more space, I can just add more space later. If I have this connection, I create a transaction with a transaction function, and I pass in a callback, which gets me the transaction in. Now I can call execute SQL on the transaction, which has 4 parameters. The first one is the SQL command. You could put in any SQL command that you know of. The second parameter, the empty array that you see here, would hold all the parameters that can be bound to variables in the SQL statement. The third parameter is the function that gets executed on success. So if the query was successful, So like in this case, we just loop over the results and we would render all the items. And the fourth function down below is the function that gets triggered in case any error has occurred, like you provided a wrong SQL statement or anything like that. And that's it. And as I said, you could just exchange the select star from table with an insert command, with an update command, with a delete command. So anything that you could do with a normal database or with SQLite in particular, you could put into here. That's all it needs. So pros and cons. Pro, we have versioning support, which I guess is really important for a long-running application or a long-term application, because you exactly know which version the client is running on, and you can write like migration scripts and go further and further and further, so you know exactly how to come from point A to point B, and so on. Yeah, as I said before, it's a real database running in the browser, which is really awesome for me, which basically also is a con, because you need to be aware of the complexity of a database, and if you as a front-end developer are not that familiar with databases, it might be a bit hurdle to get into that. And the biggest con is actually it's no longer part of the HTML5 specification anymore. So in, I think it was September 2010, it got removed from the HTML5 specification, mainly because most browser vendors used SQLite as an implementation of that, and the W3C said you can't have a standard if we have just one method of implementing it. So if you just have one way of doing it, it can't be a standard. And on the other hand, they thought it's a bit complicated. So they came up with a different solution, which is called IndexedDB. So that's the successor. It is named being a nice compromise between the web storage, this pretty easy stuff, and the web SQL database, giving you the best of both worlds. Or in other words, it's like running a non-SQL database in your browser. That's probably the best way to put it. It's a bit complex to do all that stuff, and there's a lot of code in it. What we basically do here is, on the second line, we just create a connection to the IndexedDB database. We call it MyDB. If that worked, the onSuccess function is fired, in which we issue a version request. No questions, please. And in this version request, we create the object store. That's the place where we put the data in. We can create this object store only in this version request environment for whatever reason. If that happened, we have the database ready, we have the store available, and we could put some data in. Which could look like this. So first of all, we have to grab a transaction. Since we want to add an item, we obviously need a read-write transaction. From the transaction, we get hold of the store that we want to put the data in. And then we can simply call the put method on the store and just put anything in there that we want. So in this case, we put in an object having 2 keys, and that's it. So that's really simple to work with. Removing item is also quite easy. Again, we create the transaction, it's a read-write transaction, we grab the store that we want to delete the items from, and then we call the store delete method with the ID, with the key that should get deleted. Reading items. So again, we create the transaction. In this case, it's just a read transaction. We get hold of the store, and then we have to create what IndexedDB calls a key range. A key range defines or limits the result set that should be fetched from the store. So in this case, we say, read all the items with a lower bound of 0 and an upper bound of undefined. So any item that is in there between 0 and whatnot. We pass this key range to the open cursor method, which gets us a cursor. And then we implement the onSuccess method. The onSuccess method is called every time an item is found in the IndexedDB database. So for each item that is found, the code below here is executed, we first check if it's a valid result. We could process the value. And at the end, we have to call result continue so that the cursor is moved to the next item. That's it. So unlike the Web SQL database, where you are pretty free when it comes to defining your where statement to filter the items, the IndexedDB thinks of these, let's say, key value pairs, like the web storage. So I can always filter only based on the keys. I can define multiple keys or multiple key indexes. That's not a big deal. But in my queries, I can only filter for one specific key. So depending on the complexity of your application, you have to plan a bit upfront to figure out how to best lay out these stores and how to best interact with the application. Okay, pros and cons. First of all, again, we have versioning support, which is really good. Yeah, it's called the new standard, so this is really the future, and you should really use that if you want to store data locally. Cons. It might be a bit complicated, or let's call it different from traditional approaches, so you really need to get in this IndexedDB way of thinking and laying out things, so this, at least at the beginning, can be a bit complicated for you, but I guess once you're used to it, it's no big deal. And the last downside, unfortunately, not many current browsers do support it right now. So it's still on the rise, but yeah, it will come accordingly to the W3C, but yeah, currently, I think just 3 or 4 browsers do support it. Which leads me to browser support. That's probably always the question for us web developers, right? So how does the browser support all that stuff? As you can see, the web storage one, this easy key value stuff is supported by all the browsers, and really old ones like IE8 do support it. Web SQL is also supported by all the current browsers. IndexedDB, as I just said, only by Internet Explorer, Firefox, and Chrome. And the file API just by Firefox and Chrome. So depending on your target audience, it's probably quite a tough choice to figure out which store you should really use. So far, we were in a lucky situation. We mostly work for companies and do like internal applications. So it's really easy for us to know which browsers are supported. Like in most cases, when we dealt with these stores, we were focusing on the iPad. And then we were using the Web SQL database. If you really want to target a broad audience, I would not say that you're doomed, but it's really hard to figure out how or which store to really use and how to make best use of it. There are a few JavaScript libraries that act as a layer on top of it, so they would figure out which stores are available and offer some kind of global or unique interface to it, so you do not really care about the implementation part. But as you have seen, all these different stores are different from each other, so providing one layer across all is really hard to figure out all this stuff. So you really need to figure out what you can do or what your audience is, and then think which way to go. So browser support is one problem. The other problem is storage limitations. Because again, every browser has different settings or different limitations. So in most cases, the numbers I've shown here are the minimum values. So in some cases, users can request more space. But you see, you don't have some baseline where you can say this is really space that I can use for my application. It really ranges from 5 megabyte to 500, and Chrome goes all the way to unlimited. So it's really hard to figure out how much space you can use. And if you really go down to 5 megabyte as the bare minimum, it really depends on your application if that makes sense just to work with 5 megabytes. So it might be way too little to work with a serious application. And I almost made it. Just need to wait 10 seconds. Okay. Oh, I got some more. Right. So we were talking about data locally. The question is, how can we sync it? Well, on the one hand, we could write the implementation on our own, which can be probably hard. On the other hand, maybe we should use something that is out there. An interesting idea is a library called PouchDB, which is a JavaScript library that would interact with a CouchDB NoSQL server. So it provides all the logic to sync the local data back to the server, and it offers a really easy API. So I would just create a PouchDB object, put the data in, and when I'm ready to sync the data, I call db.replicate.to and pass the URL of my CouchDB server, and it just takes care of pushing everything to the server side or downloading stuff again. That's really easy. So if you can afford having a CouchDB server somewhere for your application, that's easy to go. Otherwise, you have to come up with your own solution. That's it from my side. Thank you.